All right, number 9, island bridge problem. Supposedly you work for a construction company that's planning to build a bridge from the land to point on an island in a lake. The only two places on the land to start the bridge are point X and point Y, which happen to be exactly 1,000 meters apart. Point X has better access to the island, to the island, but is farther from the island than point Y. To help decide between X and Y, you need the precise lengths of the two possible bridges. You got a little diagram. How long would each bridge be? So I believe you guys were able to do this, right? Is that true? Did you get part A? Okay. What did you get? So for part A, you need to figure out what this angle is right here. What's that angle? 80 degrees. Okay. So then if you go 1,000 over sine of 80 equals, okay. Okay, 679.45. You confirm that? Okay, and then thank you. We can also do, hang on just a second, 1,000 over the sine of 80 equals, awesome. Erica? Yep, okay. Did someone, you need to, yep. All right, are you guys all okay on that? That's just what we were doing, the law of sines. Okay. All right, then from there it says if constructing the bridge costs $370 per meter, how much money could be saved by constructing the shorter bridge? So 861.13 minus 679.45. How much shorter is the shorter bridge? Anybody do this math? Okay. 181-ish? Okay. The answer to 9B. No. How much shorter? Oh, no. What's the answer to how much shorter the bridge is before you multiply? Okay. You just. Oh, okay. Okay. I see. Okay. So you took this and went times 370, took this and went times 370, and then subtracted those. Okay. Okay. That's fine. As long as you're in the ballpark, you're okay. All right. How much could be saved by constructing the shortest possible bridge? Okay. So what they mean by that is if we go back to this diagram, they're like, what if we just draw a bridge directly, or build a bridge, I mean straight from there to there. That would be the shortest possible bridge, okay? So yeah, so what we have to do then is we are doing our old friend, the right triangle trigonometry. So I'm going to use SOHCAHTOA. I know this angle right here. What is the side that I'm looking for relative to that 58-degree angle? Me too. That's the opposite. What is this side right here? That's the hypotenuse. Who uses the opposite and the hypotenuse? Sine. Good. So what we could do to figure out that length is we could say the sine of 58 degrees is equal to the opposite side, which is the one that we're trying to find, divided by, what is that side right there? Right, but we know how long it is. 679.45. Good. That is side X. And so notice we could have done the same thing. We could have flipped it around and done the sine of 42 equals the opposite side divided by the other side, 861. Okay, and you should get the same answer both ways. So to figure out the opposite side, you would go 679.45 times the sine of 58. We should be in degrees. 576.2. Okay, so the shortest bridge would be 576.2 meters. So if you multiply that by 370, how much would that cost to build? $213,000. .12. Okay. Thanks. So how much does that save? Because you subtracted that from this number? Okay. What was this number? For how much would it cost to build the shorter of the two bridges? Okay. And then, okay. And then when you subtracted those two, you got 38,000. Sorry, one more time. 381. Okay. You got that, Mylena? She's sick at home, but I'm sure she'll be watching this video later this weekend, just like Gus did yesterday. I don't know if you guys noticed. He was gone yesterday, watched the video, came to class, homework done, totally understands everything. Uh-huh. Danica, this is how much you would save building the shorter of the two bridges. This is how much you would save if you just built a bridge directly from the side to the island. Okay. Okay, did you guys have any other questions, or was it just that one? 10 and 11? 10C. All right, Amos walks 800 feet along the side next to a field. Then he turns at an angle of 43 degrees to the sidewalk and heads across the field. When he stops, he looks back at the starting point, finding a 29-degree angle between his path across. So there's the picture, okay? How far across the field did Amos walk? So if this is 43, what's this? All right, she is a machine. So if I want to find how far Amos walked, I am going to go 800 divided by the sine of 29 equals how far divided by the sine of 137. Okay? So I trust you guys can find that number by cross multiplying and then dividing. Will you do that now? Oh, you. Alrighty. Yeah, maybe we'll just go 1,125. Let's just do that. Holding. I like that answer, Olivia. The other one's 800. That's a bigger angle. That seems about right. Will? Hero formula is the square root and the semi-perimeter. Okay, how far does he have to walk to go directly back to the starting point? Didn't we just figure that out? Oh, the other side? Got it. Okay. Okay. So let's find the other how far then. Right. So let's go 800 sine of 29 equals what is this? 14? You say 399? Uh, so yeah, A is actually this. No, no. Okay. Well, you need to be more like Gus and take responsibility for your own learning and watch the video on your own time. Liar. Liar. Really? All right. Amos walks 5 feet per second on the sidewalk, but only 3 feet per second across the field. Which way is quicker for him to return to the starting point, by going directly across the field or by retracing his original route? So if he goes directly across, that distance was 1125. And if he walks at 3 feet per second across the field, what is 1125 divided by 3? I'm going to say that is 378. 3 goes in there, 9 times remainder of 2, 22, 7. Oh yeah, 375 seconds. I think it's going to take him more time to figure this out than if he just starts walking. If he goes back the way he came, then that means he has to walk 399 feet at 3 feet per second, so that's 133 seconds. And yes, he has to walk the original 800 feet from where he started, at 5 feet per second. So that's 160 seconds. Is that right? So actually, if you add those up together, you get 293 seconds. So he could save over a minute by walking back the way he came. Thank you, math. I don't know, maybe when you grow up, you'll calm down a little bit. You wouldn't maybe believe it, but when I was a younger man, I was really shy, quiet.
You're going on recording your memoir.
Yeah. All right, number 11, use the law of cosines to find the measure of angle A. Great review for the quiz that we're going to have in just a second, okay? So, angle, go ahead. What'd you say? No, not for angle A. Okay, let's do A. 7 squared. No. Just 4 and 10. Yeah. I'm really glad. No, it's okay, because you've learned, and so that's what's most important. It's not a big deal that you got that problem wrong on the assignment. What is a big deal is that now you have a better understanding of the formula. So 49 equals 116 minus 80 times the cosine of A. 49 minus 116 is 51, 61, 67. So to find angle A, I need to go the inverse cosine of negative 67 divided by negative 80, which is 33. Okay, so I'm going to round that to 33 degrees. What's the matter? It does. Sorry. Jeez, Olivia. That was savage. Okay. Sorry. All right, part B, use the answer to part A. Don't round off in the law of sines to find the measure of angle C. So for that, I need to go 7 divided by the sine of 33.123 equals, I'm trying to find angle C, so 10 divided by the sine of C. Now we have not yet done a problem like this using the law of sines where we're trying to find the angle. Okay, so when I cross multiply and then divide, I'm not getting the answer for angle C, I'm getting the answer for the sine of angle C. Okay, so we're going to have one more step to do when we're done with this. So I have to go 10 times the sine of 33.123 divided by 7. What is 10 sine 33.123 divided by 7? And please don't forget to close your parentheses. 0.7806. Okay, obviously that's not the measure of angle C. Okay, that's the sine of the measure of angle C. And so in order to find angle C, I have to take the inverse sine of that. Okay, so that means angle C is going to be 51.31 degrees. I think I see where we're going here. I bet next we're going to figure out angle B, huh? And then we're going to find the area. Okay, find the measure of angle C again using the law of cosines and the given side lengths. Alrighty then. Bless you, my child. Okay, so if I want to use the law of cosines to find that side, now I'm going to do this is what Kai was doing to start with. 10 squared equals 4 squared plus 7 squared minus 2 times 4 times 7. Remember, Gus, to only use the 4 and the 7, not the 10. Cosine of C. You guys okay with that? Okay, so 100 equals 16 and 49 is 59.65 minus, so that means C is going to be the inverse cosine of 35 divided by negative 65, which is what? Okay, which is not the same as what we got before, right? When we figured out what the measure of angle C was before, we got 51.31. Hang on just a second. Yes? Well, you did something wrong. You did something wrong. That's what I did 3. Hold on, I gotta even wait up just a second. Okay. All right. Inverse cosine. I know. So many buttons. How come you guys got 128? It's my fault, Kai. All right. That's what I said. That's my fault. So the only person that was wrong in this scenario was me. Okay, and so you do get 128.68. Okay, and that is important because what we need to notice about these two things is that they add up to 180 degrees. We are going to talk more about that next week. Okay, that is the topic of Monday's lesson. And before we put these away and do the quiz, what did you notice about this triangle that made that happen? Oh, never mind. I was thinking it has an obtuse angle in there, but we've done those before and it worked out just fine, so don't listen to me. I have no idea what I'm talking about. All right, will you put your stuff away?